So 8.6, solving rational equations. This is the last section. Our test is next Thursday. So when we solve rational equations, there's two options. First one is to cross multiply. Now, that only works if you have a fraction equal to a fraction. Okay, if I have two fractions added equals another fraction, it won't work. If I have two fractions plus a constant equals another, it doesn't work. It has to be a fraction equals a fraction. That's it. Okay, that's the only time cross multiplying will work. The second option is canceling out the denominator, or I say clearing fractions. Getting rid of any of the fractions. It's turning it into a problem that we learned how to solve last semester. Okay? So what you're going to do is you're going to find the least common denominator of the entire equation. Okay? Then you multiply the entire equation by that. Every piece of it. Every term. Okay? Anything that's separated by an addition, subtraction, or equal sign, you are going to multiply by that. Okay? Then your denominator should be gone. So then you solve it like usual. Now add this in. You may need to factor with x squared. Well, you only factor when it's x squared and an x term. If you have two different variable terms, two different types of variable term, I should say. So an x squared and an x. If you have two x terms on each side, it's just like a linear equation. It's easy to solve. You don't have to factor. Okay, but if I have an x squared and an x term, two different types of variable terms, then you're going to have to move everything to one side so it equals 0, factor, quadratic, something like that. Okay? Last thing, make sure that you check your answer. There could be extraneous roots. Okay, meaning roots that are not actually, or solutions that are not actually solutions of the equation. Okay, it comes out of the fact that if you multiply, you might go from something that has x to something that has x squared and add another possible root. Okay? So make sure you check for extraneous roots. Alright, so first examples. So what method am I going to use here? You got to be able to recognize the first one. Why can I use the first one here?
They're both fractions.
Yeah, it's a fraction equals a fraction, right? So this is the case that I can cross multiply. So I'm going to multiply the top on one by the bottom on the other. And then the other one do the same thing. So when I do this, 3 times x minus 7, you are multiplying 3 by 2, something that's two terms. So you got to take in multiplies each. So we do that, we say 3 times, and then we put x minus 7 in parentheses. What am I going to have to do then? Distribute. So this would be 3x minus 21, right? Now, if you can recognize and just do the distributing right away, that's fine. Go right down to there, I don't care. The other side, what am I going to end up with? 10x. Now, for some reason, you can do this by dealing with the constants first, but for some reason, everyone who does the constants first, not everyone. A lot of people who do the constants first, start moving constants around, make mistakes. So when I look at this, I see I have two variable terms that are the same type of term. Okay, so I can do is I want to get those two terms together. Okay, now the more complicated, I deal with the variables first before I mess with the constants. So if I have a 3x and a 10x, well, there's more stuff on the left. I'm going to take away the 3x from both sides and get it off that side. Okay. So now, when I'm done with that, there's two different variable terms, but they're the same type of term. So when I get them together, I can combine those. So now I'm down to negative 21 equals 7x. So now how do I solve that? 7. So negative 3 equals x. Now, before I do anything, I'm going to check it. So to check it, I go back and plug it in. It's going to be 5 times negative 3 on the bottom there equals 2 times negative 3 minus 7. So when I simplify, this is going to be 3 over negative 15. This is going to be 2 over negative 10. So how do I simplify those? We're just going to simplify. We don't when we're trying to check it, you can't move anything each side. You have to simplify each side individually and then see if they're equal to each other. So how do I simplify 3 over negative 15? Divide each by 3, right? Or reduce by 3. So it's going to be what? 5. What about here? Yeah, divide each by 2. So it's 1 over negative 5. So guess what? It works. So x equals negative 3 is my solution. Okay? So now, with your partner, I want you to go step by step and talk to each other as we do it. Do not just each of you do it on your own. With your partner, do the next one. Talk to each other.
I would do I'm going to do the x first, so plus 4, so 9x plus 15 equals 4, minus 3, right? So I did that, negative 3 equals 3, negative 1/3. Okay, that's what we'll do. Okay. Check this first. You replace all the x's in the original with the negative 1/3. Yeah, just replace all the x's. So you go boom, that equals negative 1. Negative 4 equals 5. I don't think it works. I don't think it works. I think it's an extraneous false solution. Negative. Yeah. So would it be wrong though? So one might work. I get so we got negative 7. Why did you do that?
All right, what do we get?
Negative 1/3.
Negative 1/3. Do we check it?
Yep.
Yep. Does it work?
Nope.
No? All right, this involves fractions, so gotta be careful. So negative 4 over negative 1/3 plus 3. Okay, equals 5 over negative 1/3 minus 3. Okay.
Yeah, I was multiplying the fraction and the thing.
So it's equal, so we got to add those on the bottom, we got to add these together. So to do that, I need to have them both in terms of the same fraction with the same denominator, right? So let's say I had 3 pies. And I divide all those 3 pies into thirds. How many pieces am I going to have? 9. So 3 pies divided into thirds is 9/3, right? So if I have negative 1/3 plus 9/3, I'm going to get what?
8/3.
8/3. Okay? 5 over negative 1/3 minus 3/3. So we said 3/3 is 9/3. So what's negative 1/3 minus 9/3? Negative 10/3. Okay. So now, can I have a fraction inside of a fraction? No. So you got a couple options. What I would do is, because it's a number divided by a fraction, instead of dividing by that fraction, I would do what? Multiply by its reciprocal. So negative 4 times 3/8 equals 5 times negative 3/10. So what's 4 times negative 4 times 3/8? 12/8. Negative 15/10 over here. And I got to reduce and see if those end up being the same thing. So 12 and 8, what goes into both those? 4. So this is going to be what? 4 goes in there, it'd be negative 3/2. 15 and 10, what goes into both those? 5, so it'd be negative 3/2. Boom. Yeah.
The first step I did, I subtracted my 12 on both sides, and then subtracted my 5. And then I did like negative 2,
Which is negative 1/3. What you're repeating is 1/3. I don't like using decimals because I think they're much harder to work with than fractions, personally. Especially if I don't have a calculator. All right, next one. Can I use cross multiplication here? No, why not?
There's a whole number.
Yeah, there's some craziness. Well, you can always turn a whole number into a fraction, but is it just a fraction equals a fraction? No, I got a fraction plus a fraction equals, so yeah, no, can't use cross multiplication. So this is the case where I'm going to clear fractions, or I'm going to multiply by the least common denominator. So, what are my denominators?
2 and x.
2 and x. So what's the least
2x.
common denominator of 2 and x?
2x.
2x. Okay? So, I'm going to take and multiply everything by 2x. I multiply every individual term or every piece by 2x. So now, there's a couple options to do this. Okay? Well, you can multiply then simplify, or you can simplify then multiply. I don't care how you do it. Okay? When I showed my other hours, I started with simplify then multiply, and it was messing people up. So let's do the multiplication and simplification, and then I'll show you the other way, and you can do whatever one you'd like.
Are you going to multiply that 2 by 2x to make it 4?
Nope.
Okay.
Because this is really what?
Like
2x is really over what?
Over
1. So the only thing we multiply the 2x by is the what? Top.
Okay.
The numerator, right? So this is just going to be what? 14x over 2. This is going to be what? 6x over x. This is going to be what? 6x. So now, when I go to solve this, or go to simplify first, what's 14x divided by 2? 7x. What's 6x divided by x? 6. Okay. Now, how I would have done it is I would have just multiplied, I would have simplified first before I multiplied. So I would have gone up here and said, okay, well, if I have 7 halves times 2x, so I'm multiplying by 2 and dividing by 2, so those cancel, so I'm left with just what? 7 times x. Here I'm multiplying by 2x and dividing by x. So those x's are going to cancel, so I'm left with just what? 3 times 2, 6. And then over here I have 3 times 2x. Okay? So it doesn't matter if you multiply then simplify or simplify then multiply, you get the same thing. Whatever makes most sense for you. Whatever's not going to mess you up. Okay? Don't care how, like I said, how you do it. Alright, so now when I look at this, I see, okay, I got x terms on both sides, but they're the same type of term, right?
Yeah.
So what I can do is just get them together first, and then work on solving. So I'm going to, there's more stuff on the left, so I'm going to take that and move it over there, because there's less on the left. Okay, so that's going to end up being what? 6 equals negative 1x. And then what? Divided by negative 1. So I get what?
X equals
Negative 6. Alright, so let's check it. 7 halves plus 3 over negative 6 equals 3. So I got two options. I can come up with a common denominator, so I can add the two fractions on the left, or I can realize, hey, look what happens. 3 over 6 reduces to what?
1/3 or 1/2.
Negative 1/2. So what's 7 halves plus negative 1/2?
6 halves.
6 halves. Well, what's 6 halves? 3. So 3 equals 3. It works. All right, next one. Talk with your partner right now. See if you can just come up with the common denominator. So what do you think the common denominator is? Talk with your partner. So what is the smallest that both of those go into?
Maybe 50.
Okay. So what are we thinking? Anybody got it? I heard a few different things. 20, 20x? Okay. 10x? 5? 5x? What's that?
Are we able to do 5x and parentheses like 10?
5x. You could. It's not the least one. So there's a couple that would work. 20x would work. The 5x and 10, which would be 50x, would work. Those aren't the least common denominator. The least common denominator is 10x. Okay, because they both have to divide into it. They both divide into 20, but that's not the smallest, right? 10 goes into 10, 5 goes into 10. But you need to have an x. Because if you don't have an x, you got to divide that into that too. So it's got to have an x. The variables, if it's just a variable, it's easy. Just put whatever variable they have. Well, I guess if it had x squared, then it would be you need an x squared, and you'd also need a 10. But it's not. It's just 10x is the least. Now, if you use 20x, if you use 50x, it'll work. If you don't use the least common denominator, it'll work. It's just going to be, for these, it's not a big deal too much. But if we don't use the least common denominator when they're more variable expressions, then it makes things a lot harder. You're adding complexity. You're adding another layer. It's going to end up being having to solve x squared, x cubed, x to the fourth. Okay? It's going to make it harder to solve. Okay? So if you don't get the least common denominator, this one's not a big deal. You're just going to have to reduce at the end, maybe. Okay? But if you don't use the least later, then it's going to be a little more challenging. All right, so we're going to do 2 over 5x times 10x plus 1 over 10 times 10x equals 8 over 5x times 10x. All right, so when I multiply those, here I get what? I get 20x over 5x plus 10x over 10 equals 80x over 5x. Okay, now we can reduce. Or I could have reduced earlier. If I were to reduce earlier, what? These x's would cancel. 5 goes into 10 twice, so it would be just what? 2 times 2, which is what? 4. Is that what I get when I reduce this? X over X cancel, so 5 goes in 24 times. This one, what would happen? Well, the 10s reduce each other, right? So I just have what? X. Here, the X's cancel, so it's just 80 divided by 5. Let's see, 5 goes into 8 once. 3 left over, so the 3 and the 0 become 30. Goes in once. 30 divided by 5 is... Okay? So now, subtract 4. X equals 12. So let's check it. Alright, so let's see.
Now, couldn't you subtract the 2 over 5x to the 8 over 5x since they're the same denominator?
Sure. Yeah, you could. Yeah. So subtract the 2, get 6 over 5x, and cross multiply. Yeah, that'll work. Alright, so it's going to be 2 over 5 times 12 plus 1 over 10 equals 8 over 5 times 12. So, let's see, 5 times 12 is 60, so this is 2 over 60. Well, I need a common denominator here, so I'm going to do this right now. So I need this to be 60, so I'm going to multiply by what, 6 over 6? So it's going to be 6 over 60, 8 over 60. So 2 60ths plus 6 60ths is 8 60ths. So it works. So that equals 12. Alright, so that's the case where you had common denominators. Same thing here. Now, if you wanted, yeah, you could add and cross multiply, or what's the common denominator here? 2x and the other one is x plus 1, right? There's nothing in common, so what you're going to do is multiply by both of those. So this is going to be 3x over x plus 1 times 2x times x plus 1 minus 5 over 2x times 2x times x plus 1 equals 3 over 2x times 2x times x plus 1. Alright, now here's where reducing first is immensely helpful. Okay? So in that first one, I have what? X plus 1s will reduce, right? This is really over 1, so I have an x plus 1 on top, and an x plus 1 on bottom. So those cancel, so what am I left with? Yes. 3x times 2x is 6x squared. Now, here's where you got to be careful with this one. Well, what can I reduce first? Yeah, the 2x is reduced, right? This is really negative 5 times x plus 1. So I got to take the negative and the 5 and distribute it to each. So it's going to be negative 5x minus 5. Okay? Now on the right side, what's going to happen? 2 x's are going to cancel. So what do I have to do now? I take and distribute the 3. 3x plus 3. So now, when I look at this one, how many different x terms and different types do I have? 2. I have 2 different types. I have 3 total different variable terms, and I have 2 different types, right? I have 1 x squared term, and then I have 2 x terms. So this is the case where I have 2 different types. So what I have to do is I have to get everything to one side, and then solve by factoring, quadratic, etc. Got to get it equal to 0. So I can use that zero product property. So I'm going to have 6x squared minus 8x minus 8 equals 0. So how do I solve that? Trinomial? So how am I going to factor that trinomial? So factors of negative 48 that add to negative 8. So I need a negative and a positive, right? Or 12. And I gotta have what? Negative 12x, positive 4x. So the whole reason why I do this is so now I gotta figure out, okay, what do I need to replace this middle term with? So that negative 8x, I replace it with negative 12x plus 4x.
We haven't done this in so long.
Did it on the review rules last week or the week before.
I mean, that usually goes through the shortcut. Like we
Why can't I use a shortcut in this one?
Sounds like there's no one.
Yeah, x squared has a coefficient of 6, so I can't do it. So now what do we do? Factor by grouping, group the first two. What can I factor out of those?
6x.
6x. So what's left when I take a 6x out? Minus 2. Okay, factor the next group. So, since this first term in the next group is positive, I put a plus there. What can I factor out?
Minus.
Did it work?
No. Yes.
Didn't?
Oh wait, never mind.
What are we going to look at to see if it worked? Are the two things inside the parentheses the same?
Yep.
Yeah, so it worked. So now if those are the same, I can take one of those out of each. So when I factor it out, I only write it once. So what's left if I factor that out? 6x plus 1. Yep. Now I need to, the whole reason I did this is so I could do A times B equals 0. Right? So if A times B equals 0, then what must be true? Either A equals 0 or
B.
B equals 0. The whole point of doing this is so I can break it down into smaller equations that are easier to solve using what's called the zero product property. Okay? So that's why it has to equal 0. Two things multiplied together to equal 0, one of the two's got to be 0. If it's not equal to 0, it doesn't work. You can't break it into smaller problems. So, what's the solution to this one? 2. How do I solve this one? Subtract 4. Divide by 6. So, x equals... Now,
Check.
check them. They actually both end up working, but for time's sake, we're... So you go to the next one. Now, what I will say this, the quick check is look at them and see. If I were to plug those in, would I ever get 0 on bottom? That's generally what causes a problem. If I were to plug in 2, would I ever get 0 on bottom? If I were to plug in negative 2/3, would I ever get 0 on bottom? No. Those are the quick checks. Okay? So now this one. Can I use cross multiplying on this one right the way it is?
Nope.
No. So now the nice thing is I only have one denominator, right? The only denominator I have is x minus 2. So I'm just going to multiply everything by x minus 2. So I multiplied everything by, there's only one denominator. I multiplied everything by that denominator. So again, now the first one on the left, the 5x over x minus 2 times x minus 2. Well, the x minus 2's do what? Cancel. So what am I left with? 5x. What do I got to do here? 7 times x minus 2. No canceling, you got to do what? So just 7 times x minus 2. So what? Distribute 7x minus 14. The next one. Now these cancel because I have x minus 2. I'm dividing and multiplying by x minus 2, so those cancel. So I'm left with just what? Plus 10. Well, I have two x terms, but they're the same type, right? So I can just do what? Well, let's remove one from one side. So I want to take the 7x off that side. So if I take it off this side, I got to take it off the other side, right? So this will be negative 2x equals, well, what is left over here? Negative 14 plus 10. What's negative 14 plus 10? Negative 4. Okay, now last thing I'm going to do is what? Divide by negative 2. So x equals 2. Okay? So now I go back and I plug it in. As soon as I do that, what should be happening right now? Got a problem. Houston, we have a problem. What's my problem?
You get a 0.
You get a 0 on bottom, right? Can you ever have 0 on bottom?
Nope.
No. So what does that mean? There's no solution. That's an extraneous solution. No solution. What questions do we have on that? Now the next one is just x equals 2. How'd you come up with that? Don't even have to worry about that. You don't even have to worry about multiplying at all. Why? If you recognize, but even if you recognize that if the denominators are the same, you don't even have to put pen to paper. Pencil to paper. So if two fractions are equal, if the bottoms are equal, it must also be true. Top's got to be equal if two fractions are equal. So is x equals 2 my answer?
Yes.
No. Why not?
0 on the bottom.
Yeah, because if I plug it in, I get 0 on bottom. So guess what that means? Solution. So make sure you recognize that the bottoms are equal. If you just have a fraction equals a fraction, if the denominators or the numerators are equal, either one are equal, then the other one's got to be the bottoms or the tops, depending upon which ones are equal. Also, over here for future. Done? What questions do we have? All right, here's your practice.
See you.